Assalamualaikum and good day everyone. I'm Dr. Asma Alia Muhammad Buhari for BQS568 Sustainable Construction. Today we'll be talking about subtopic 3.3 Sustainable Materials and Waste Management. Green and sustainable often used interchangeably. They actually have a different meaning. All sustainable products are green, but not all green products are sustainable. Green products and materials are those have characteristics such as energy efficiency, renewable energy, low impact on the environment, low impact on health. Making green products sustainable has to do with how they are developed, produced, harvested, and how the process impacts the future. For example, the wood lumber is generally considered a green product because trees are renewable sources. However, lumber manufacturers are harvesting forests in a way that will wipe them completely out, then it is not sustainable practices. The correct way is harvest the lumber in a way that will allow the forest to continue to flourish and provide a continual supply of trees for harvesting. Another consideration of example is a fluorescent light bulbs. Compared to a traditional incandescent bulb, CFS bulb require less wattage to produce the same amount of light, making them more energy efficient. CFL bulbs are also up to 10 times longer than a traditional bulbs. These benefits appear too great and would seeming making CFL bulbs a green product. However, CFL products are not sustainable for a couple of reasons. They cost more to produce and they contain mercury, which both hazardous to the environment and your health. Recycled materials are great building materials, especially if they are locally sourced. For examples, the recycled materials include reclaimed wood, recycled metal, and recycled glass. Like wood and metal, recycled glass has found many popular uses as a sustainable building materials. Common application for recycled glass include tiles and countertops. Not only these recycled materials are green, sustainable product, but they can add great character to your building. Sustainable materials is also related to sustainable waste management. It is time to zero in the waste management. The Malaysian Carbon Reduction Environment Sustainability Tools (MICRAS) is helping to quantify positive effort in incorporate green standard into the construction industry. MICRAS also provide incentives for construction projects to reduce on-site waste and carbon emission. The incentives are achieved through on-site incentives and green technology tax incentives. On-site incentives such as increased efficiency through green construction site with an eye to reduce waste have been proven to work more efficiently. Lean management is being introduced refers to the efficiency in process. In general, monitoring and optimizing for an imposed efficiency standard tends to lead to a better outcomes. With these standards include precise objectives such as reducing on-site waste and avoiding pollution. Green technology tax incentives is rewarded by the Malaysian government with a green technology tax incentives which will be allocated for a project which began from 2013 to 2020. Since 2009, the Green Building Index has prompted the Malaysian government to invoke various strategies to spur green construction activities. Among these activities is the rebranding of the Malaysian Energy Centre and the launch of National Green Technology Policy or NGTP. If a project is certified as a green by NGTP, it can receive 100% tax exemption on any capital expenditure that it needs to obtain that certification. The Green Technology Tax Incentive here is a short list of what construction projects can expect to receive benefit on. First is on the energy efficiency. This category includes high efficiency motors, motion sensors, variable speed drivers, and insulation walls. Water efficiency. This category includes a water recycling system or a rainwater harvesting system. Indoor environmental quality. This category includes air filters that help to clean the air and improve IAQ or indoor air quality are all included in the auspices of the updated tax agreement. Integrated waste management. Any initiatives that has to do with waste treatment, waste recovery, and waste management is included in the updated tax agreement. The next discussion is on the ways to dispose of waste. Proper waste disposal is one of the core principles of a green construction, and it is also essentially important if a project is to remain in the compliance with the Sustainable Construction Excellence Centre, Mampan, and Construction Industry Development Board, CIDB. New technologies being introduced into the marketplace and the assistance of this organization. There are 6 innovative best practices that has been identified. The first is the 3R construction waste reduction. 3R stands for reduce, reuse, and recycle. In Malaysia, the National Solid Waste Management Policy described clearly this general strategy. As of 2017, landfill dumping constitutes a common but inefficient method of waste disposal in the majority of the Malaysian construction industry. From 70% to 80% of materials in the landfill dumps within a country are recyclable materials. Number 2 is on the reduction of a waste through careful pre-planning. Of the 3Rs, the most effective concept of a sustainable project has proven to be the concept of reduction. If there is a less overall waste on site, the monies that would be used to reuse and recycle can be saved. Additionally, the concept of having materials that need to be reused and recycled implies a surplus of materials on site, which means there is some sort of inefficiency that may be addressed within the project. Number 3 is the imposition of the 3R through law among contractors. In a study conducted by the National Solid Waste Management Department, only a small portion of contractors are introduced to the concept of 3R through regulation, contract requirement, or law. One of the best practice methodologies in the Malaysian government has to impose limitation on landfill dumping and incineration. A secondary method for the introduction of 3R concept is through university education. Number 4. Designing for disassembly, reuse, and adaptability. Another component of pre-planning that can reduce waste is to design buildings that support reuse, adaptation, and disassemblies. These buildings provide both short and long-term benefits for their residents and the surrounding communities. Another advantage of this practice is the avoidance of building removal in total. Materials within the structure can be more easily and cost-efficiently directed and disassembled for another uses in the future. Number 5. Preparation of deconstruction. Projects that include certain types of material rather than other are more constructible than others. Taking a cue from Department of Housing and Urban Development in the United States, best practices here would include the following. Wood frame building, for examples. The use of specialty material that resell well. Use low-quality mortar with a high-quality bricks. Structurally sound building. Number 6 is on incentivizing contractors. The monetary value of waste has been shown to be a good incentive to entice contractors to participate in 3R initiatives. Pre-planning is essential here, as record shows that contractors are less likely to believe in or to implement 3R standards if they are unaware of the monetary advantages. However, the attitude of contractors also plays a role in implementation. So here are some best practices in the solid waste management in the Malaysian construction industry. The first concept is known as the design waste out. Design waste out can be done through the prevalent software building information modeling, BIM, and the industrialized building system, IBS. It is possible to design waste out of a construction with these two tools. BIM enables architect, contractors, and other workers to input data on a building and generate three-dimensional digital models of a building in the different stages of its life cycle. Embracing BIM would limit errors and changes in design stage. Under IBS, building parts are manufactured in a controlled environment and then delivered to the site for assembly. Prefabrication on-site assembly would certainly minimize wastage. Reduce waste on-site, insufficient scheduling, material procurement, and site management are some of the major causes of our waste generation. Reduce material waste during construction is as simple as making certain tweaks of delivery schedule, material order, and the site management technique. Next, reuse materials. Many construction materials can be used multiple times. By maximizing their usage, contractor could ease the consumption of virgin resources, such as timber, for example, is conventionally reused up to 4 times. Using recycled waste, we have discussed this previously. Responsible disposal, this is very important, where the contractor need to be responsible on where they are going to dispose the waste. Waste was often dumped at landfills, illegal dump sites, and on private properties. Education to educate the contractor is very crucial. That's all for this week. Thank you very much. And if you have any question, please drop me an email at asmaalia@uitm.edu.my. See you next week. Have a great day, everyone.